There are two bags A and B. Bag A has 4 white balls and 6 red balls. Bag B has 2 white balls and 3 red balls. Each bag has an equal chance of being picked. If a bag is selected randomly and 2 balls picked with replacement in bag A and without replacement in bag B, find the probability A, they are both white balls. So the first thing you're going to do is to highlight the most important part of this question. One is where we have this statement with replacement in bag A. The other one you should note without replacement in bag B. Another thing we require in this question is to draw a tree diagram which will be useful in getting the solution to this question. Let's go directly to the tree diagram. So this is how we are going to draw the tree diagram. So there are two bags, that is bag A and bag B. Both of them have equal chances of being selected, so the probability of selecting bag A is a half. The probability of selecting bag B is also a half. In bag A, remember there are 2 balls are picked, so we represent the 2 balls like this from each bag. So that is the first one. This one has white, red. Then the second, this is 1 ball. The second ball is a white, red. Then there is this one for this branch is white, red. Then in bag B, again we select 2 balls, so white, red. Then the second ball, white, red. Then this branch, white, red. So this is the first ball, and this one is the second ball. So kindly note that. After representing this, again, it is very important to note that is name this branch. This is A, from bag A, white, white. So from bag A, white, white. Then there is from bag A, white, red. Then there is from bag A, red, white, red, white. There is this one from bag A, red, red. Then there is this in bag B, white, white. There is B, white, red. There is B, red, white. Bag B, red, white. Then there is bag B, red, red. That one is very important. Let's go now to filling the probabilities. So let's start with, this bag A. Bag A has got 6 red balls and 4 white. So the probability of picking white is 4/10. Red is 6/10. Remember this one, in bag A, the balls are picked with replacement. With replacement mean nothing will change. The total number will not change. Once you pick a ball, the total will not change, and that ball is replaced. So in the second, when you're picking the second ball, still the probability remains. This is picking white is 4/10. Then red is 6/10. Again here, white is 4/10. Red is 6/10. Nothing will change. The total will not change because the balls are being replaced. Now let's go to bag B. B has 2 white balls and 3 red balls. So the probability of picking white is 2/5. The red is 3/5. Again, now when you come to picking the second ball, the total will change. Like in this case, we've picked 1 white, so the whites were 2, so 1 white will remain, and the total will change to be 1/4. So this branch, remember the total probability in each of the branch must add to 1, so the other one is 3/4. In the second branch, you've picked red, so white will not be affected, but the total will be affected. So white will remain to be 2, but the total now is 4. So again, when you pick red, the reds are 3, so 2 will remain, and the total will be 4. So that is what we mean by without replacement. Once you pick the ball is gone and it is not replaced. Having filled these, the next thing we're going to do is to go to the question. Now the question reads, the probability that both are white. So this probability is given by, where do we have 2 whites? We have that, and we also have in bag B. So the probability of picking, so this will be given by the probability of picking bag A and getting 2 white, or the probability of picking bag B and getting 2 whites. That is what you're going to do. And when you work out these, look at this branch, we have a half for bag A, where we have 2 whites, is a half multiplied by 4/10. Using this branch, multiplied by 4/10. Or we're going to add, or bag B, where we pick 2 whites, we have a half probability of picking bag B times 2/5 times 1/4. After getting that, we can simplify this one, and this will give, this is 2, 5, this one will cancel, and then we have, so this will give 1/25 plus 1/20, and this gives the answer as 13/100. So that is the solution for that part. Let's go to the second question. The probability the balls are of different colors. So the probability balls of different colors. So this one is quite big. So the probability that the 2 balls picked are of different colors will be given by, I want us to check, where do we have a probability of different? This one is 1, this one is 1, this one is another one is here, the balls are of different colors, and this one. So those are the instances where we are going to pick 2 balls that are of different colors. So let's indicate them. So this will be given by the probability of A white red, or probability of A red white, or the probability of B white red, the probability of B white red, or probability of B red white. Those are the instances where we have 2 balls of different colors. So we now need to put in from reading from these probabilities, and this is what you're going to get. So we're going to start with this probability of A white red. Probability of A is a half multiplied by white. This is the branch we are using. This is the branch. So a half times 4/10 times 6/10. So times 4/10 times 6 over 10. We go to probability A red white, A red white, A red white, it will be a half this branch times 6 over 10 times 4 over 10. Plus probability A red white, this one probability of B, now we're in B, but B white red, so it is this one, so it is a half multiplied by this a half times 2 over 5 times 3 over 4. The last one is this B red white, B red white, so a half times 3 over 5 times 2 over 4. So this is what we need to work out. So simplifying this is by 2, this 2 by 2, this one will give 3, this is 5, 2 1, this is 5, this one 3, 2 5, 5, this one will go, so this one will go with that. So this will give 3 out of 25 plus 3 out of 25 plus 3 out of 20 plus 3 out of 20. And when you do that addition, is something that you get. This is do the addition properly, you get 27 out of 50 when you do that addition. So that is part B. Let's go to part C. At least one ball is red. So the next probability is a probability at least one is red. This one will be a bit simpler. If you're getting the probability of at least one ball is red, this is equivalent to the probability of 1 minus the probability that both are white. So we don't need to get all the instances where at least one is red, means we can either decide to go the long way by getting all the instances where we have at least one is red, that is one ball or more. But instead of going that way, we can simplify and just get this. The probability of at least one ball is red is either one ball or two. So we just do it by getting one, subtract the instances where we have all the balls are white. By doing so, we'll be left by the probability of at least one is red. And this one will be given by 1 minus, we have already got the probability that both are white. The probability both are white, the first question is 13 out of 100. So this one will be given by 13 out of 100. And this one gives 87 out of 100 as our solution in that part. And the last one, none of the balls. So probability, none is white. None is white. So again, this one is very easy. If you are getting the probability of none of the ball is white, then this is equivalent to the probability that both are red. And we need to get the instances where both of them are red. One is One is red, red. So A, we have A, red, red, and B in bag B, that is where we shall get to. So we need to take those instances. So the probability that both are red is given by, so probability A, red, red, or probability in bag B, both are red. Looking at these figures, so in bag A, where we have this instance, so it will be a half times 6 over 10 times 6 over 10. So a half times 6 over 10 times 6 over 10 plus, in bag B, instances where they are red, a half times 3 over 5, a half times 3 over 5, a half times 3 over 5 times 2 over 4 times 2 over 4, which is the same as a half. So simplifying these, by 2, 3, 5. So these one not simplify. So this one will remain to be 2. So this will give 9 over divided by 50 plus this is 3 divide by this is 10, 20, and these, when you do this addition, is going to give 33 out of 100. So that is how we get that probably none of the ball is white. So it means we are getting instances where both of them are red and none of them is white. So that is how we use the tree diagram in getting the solutions to all these questions. So very important thing, remember, is to draw a tree diagram, and then you note important parts of the question. In this part, with replacement and without replacement.